Have you ever wondered why the periodic table looks the way it does, with its unique arrangement and structure? This seemingly simple grid holds a universe of information about the elements that make up everything around us, from the air we breathe to the core of distant stars. The periodic table, first conceived by Dmitri Mendeleev in the late 19th century, is more than just a list of elements. It's a testament to human curiosity and ingenuity, a guide that helps us understand the building blocks of our universe. It's like a map, not of cities or countries, but of atoms and elements. Now let's talk about the basic structure of this extraordinary table. It's composed of rows and columns, with each cell representing a unique element. Elements are organized based on their atomic number, which is the number of protons in an atom's nucleus. This atomic number increases as we move from left to right and top to bottom. But the organization doesn't stop there. The periodic table also takes into account the electron configuration of each element. That is, the arrangement of electrons around the nucleus. This gives us a deeper understanding of how elements behave and interact with each other. And have you noticed the repeating patterns as you move across the table? This is no coincidence. Elements with similar chemical properties are grouped together, creating what we call periods and groups. This recurring pattern, or periodicity, is a fundamental aspect of the table and helps us predict the properties of elements we've yet to even discover. The periodic table might initially seem complex, but it's a beautifully simple tool once you understand its logic. It's not just about memorizing names and numbers, but about understanding the relationships between elements and the patterns that govern our universe. Now that you have a basic understanding of what the periodic table is, let's delve a bit deeper into its structure and how elements are arranged. Tune in for the next segment as we unravel the mysteries of this fascinating scientific marvel. Why do you think hydrogen, the lightest element, sits at the top left corner of the periodic table? A question that piques your curiosity, doesn't it? Well, the answer lies in the organization of the periodic table, a masterpiece of scientific arrangement that has stood the test of time. The periodic table arranges elements based on their atomic numbers, which simply represent the number of protons in an atom's nucleus. Hydrogen, with just one proton, gets the first spot. Helium, with 2 protons, takes the second spot, and so on. This numerical order provides the framework upon which the entire periodic table is built. However, the arrangement is not just about atomic numbers. The periodic table also categorizes elements into periods and groups. If you imagine the periodic table as a grand mansion, then periods are its floors and groups are its rooms. The periods, running horizontally, represent energy levels of electrons. Elements in the first period have electrons in 1 energy level. Elements in the second period have electrons in 2 energy levels, and this pattern continues down the table. Meanwhile, the groups, running vertically, contain elements with similar electron configurations in their outermost shell, which means they tend to have similar chemical behaviors. For instance, all elements in Group 1, known as alkali metals, are highly reactive, while those in Group 18, the noble gases, are extremely unreactive. But that's not all. The periodic table also distinguishes between metals, nonmetals, and metalloids. Metals, found on the left side of the table, are typically shiny, conductive, and malleable. Nonmetals on the right side are generally dull, poor conductors, and brittle. And sandwiched in between are the metalloids, which exhibit properties of both metals and nonmetals. So you see, the periodic table is not just a random collection of elements. It's a meticulously arranged chart, where each element has its rightful place based on its atomic number, electron configuration, and physical properties. Understanding the arrangement of the periodic table is key to grasping the relationships between various elements. Did you know that the periodic table isn't just a random arrangement of elements? It's a beautifully ordered system, and this order is based on something we call the periodic law. This law states that the properties of elements are a periodic function of their atomic numbers. In other words, if you line up the elements in order of their atomic numbers, you'll see repeating or periodic patterns in their properties. Now, let's dive deeper into these properties and talk about trends in the periodic table. One of these trends is the atomic radius. As you move from left to right across a period, the atomic radius generally decreases. This happens because, with each step to the right, an electron is added to the atom's outermost shell, but the additional proton in the nucleus pulls the electrons closer, reducing the atomic radius. Next up, we have ionization energy, which is the energy required to remove an electron from an atom. This energy generally increases as you move from left to right across a period. The reason behind this pattern is that as the atomic radius decreases, the electrons are held more tightly to the nucleus, making it harder to remove them. In a similar vein, electron affinity also increases across a period from left to right. This term refers to the energy change when an electron is added to a neutral atom. Atoms on the right side of the table are more willing to accept an electron, and therefore have higher electron affinities. Lastly, we have electronegativity, which is a measure of an atom's ability to attract shared electrons in a chemical bond. Like ionization energy and electron affinity, electronegativity also generally increases from left to right across a period. By understanding these trends, we gain a deeper insight into the properties of elements. We see that the periodic table isn't just a list of elements, but a tool for understanding the fundamental behaviors of matter. These trends allow us to predict the chemical behavior of elements, even before conducting any experiments. So next time you look at the periodic table, remember, it's not just a chart, it's a roadmap to understanding the elements. So, why does the periodic table matter in our everyday lives? That's a question you've probably asked yourself at least once. To answer that, let's start by looking at the field of chemistry. The periodic table is the chemist's roadmap. It provides a comprehensive overview of the different elements, their properties, and how they interact with each other. Without it, chemists would be navigating the complex world of atoms and molecules blindly. Take a step over into the realm of physics, and the periodic table's importance is no less significant. It's like a cheat sheet for understanding the behavior of atoms and particles. From the atomic structure to quantum mechanics, the periodic table provides insights into the fundamental principles that govern the universe. And then there's medicine. Did you know that many of the drugs we use are derived from elements on the periodic table? For instance, lithium, found in group 1 of the periodic table, is used to treat bipolar disorder. Radioactive elements like radium and iodine are used in cancer treatment. The periodic table essentially acts as a guide for medical scientists in creating life-saving treatments. But the importance of the periodic table goes beyond these fields. It's a tool for exploration and discovery. It helps scientists predict the properties of elements that haven't even been discovered yet. Not only that, it aids us in understanding the nature of matter itself. It's like a decoder ring to the secrets of the universe. Even in our daily lives, the periodic table is quietly at work. From the oxygen we breathe, element number 8, to the silicon in our smartphones, element number 14, we are surrounded by the elements of the periodic table. So, the next time you look at that colorful chart with all those letters and numbers, remember, it's not just a chart. It's a map to understanding the world at a fundamental level. The periodic table, thus, is not just a tool for scientists, but a fundamental part of understanding the world around us. Let's now recap what we've learned about the periodic table. We started our journey by understanding the structure of this incredible table, which is no ordinary chart. It's a meticulously organized representation of all known elements, neatly arranged in rows and columns. Each element is placed in a specific spot, depending on its atomic number, which is the number of protons in its nucleus. We then delved into the arrangement of these elements. The periodic table is divided into periods, which are the horizontal rows, and groups, the vertical columns. Elements in the same group share similar chemical properties, and as we move across a period from left to right, we observe a change in properties like atomic size and reactivity. Our exploration led us to the periodic law, which states that the properties of elements are a periodic function of their atomic numbers. This law is the backbone of the periodic table, explaining why elements are arranged the way they are. This arrangement helps us predict the behavior of elements and their compounds. Following the periodic law, we explored various trends in the periodic table, such as atomic radius, ionization energy, electron affinity, and electronegativity. These trends are not random, they follow a definite pattern, enabling scientists to make accurate predictions about an element's properties just by knowing its position on the table. Lastly, we looked at why the periodic table is so important. It's not just a tool for chemists or scientists. It's a universal language that helps us understand the very building blocks of our universe. It allows us to see the relationships between various elements, predict how they will interact, and even discover new elements. So in essence, the periodic table is a testament to human curiosity and the quest for understanding the world around us. It's a story of discovery, of patterns, of relationships, and of the elements that make up everything we see and touch. Next time you see the periodic table, remember it's more than just a chart. It's a fascinating story of the elements that make up our universe.